Welcome to the End of Eternity channel. Here we look into the abyss of space where familiar words end. The universe seems endless, but where does it end? Does something that has no shape have an edge? Subscribe, and let's try to reach the edge of everything that exists together. The universe has always been a mirror. We look into it to see not the stars, but ourselves. Every telescope, every photograph of the sky is not just an attempt to understand how the world works, but an attempt to understand why it exists. Since ancient times, humans have looked up to the sky and felt a strange, almost physical, attraction to infinity. They saw the stars, but beyond them, they sensed emptiness. And in this emptiness, they sought meaning. Because if there is an edge, then there is something else beyond it. And if there is no edge, then where do we belong? We once thought the sky was a dome behind which the gods were hidden, and beneath which people lived. The world had boundaries, and that gave us peace. You knew where everything ended. You knew the center. Meaning was in the middle, not in infinity. Then the dome disappeared. We learned that the earth is not the center, but a speck of dust. That the sun is just one of many stars. That the Milky Way is just a small island in an ocean of galaxies. And with each discovery, the boundaries move further, and with them, a sense of certainty. Life has always been easier for humans when the world has an edge. A boundary is a form, a structure, a means of measurement. We build walls, maps, coordinate systems. We cannot conceive of infinity. For us, it is not space, but an abyss. But the cosmos does not obey human logic. It does not ask if we are ready. It simply is. And in this simplicity lies a grandeur that is sometimes difficult to bear. The question of the boundaries of the universe is not just a matter of physics. It is a question of faith, philosophy, and perception. Where does space end? Where does nothingness begin? And if there is an end, what lies beyond it? Scientists create models, draw shapes, flat, closed, open. But no matter which they choose, we return to one thing. A boundary exists only for those capable of perceiving it. The universe may be infinite, but our minds are limited. Therefore, a boundary is not a property of the world, but a property of consciousness. We look at the sky and see billions of stars, but beyond each one are billions more. Beyond the galaxies are clusters, beyond the clusters are structures, and so on until the gaze loses meaning. If there is no end, then everything repeats itself. If everything repeats itself, then somewhere out there might be another you, looking at the same sky and asking the same question, where is the boundary? Perhaps the very idea of an end is an illusion, invented by us to keep from going mad from infinity. Because if there is no edge, then there is no center. And if there is no center, then who are we, in a world where everything is removed from everything else? And yet, even in this vastness, we never stop searching for a limit. Because a boundary isn't just a place where something ends. It's a place where understanding begins. Every generation of humanity has asked the same question, not, what do we know? But, how far can we go? From myths to Einstein's formulas, all of these are attempts to draw the contours of infinity, to find the line between existence and nothingness, and perhaps to prove to ourselves that nothingness is also part of the universe. The further we look, the more clearly we understand there are no boundaries. But the more deeply we understand this, the more strongly we feel that there must be boundaries. The mind seeks completion. It cannot live in a world that never ends. But perhaps infinity has its own purpose? If the universe truly has no boundaries, then it resembles not a void, but a circle. A circle where the end and the beginning are one and the same. Perhaps everything repeats itself, like breathing, inhalation and exhalation, light and darkness, life and death. The question, does the universe have boundaries? Isn't just about where it ends. It's about what everything is. If there's an edge, what's on the other side? If there's no edge, where's the place for time, for meaning, for us? Perhaps people search for the boundaries of the universe to ensure that the world is finite, and therefore understandable. Because infinity isn't about space. It's about fear. When we look at the night sky, we see more than just stars. We see our own past. The light that has been reaching us for billions of years is a message from a time that no longer exists. Perhaps the universe is the same, a vast memory of what once was. And if it has a boundary, perhaps it is not in space, but in time. Not where everything ends, but where everything is forgotten. Infinity isn't distance. It's a memory that can't stop. And yet the question remains, where does the universe end? Is there a wall in space beyond which lies nothing? Or does everything return to itself, like a circle, like a thought, like a breath? We've created telescopes, satellites, equations, but the more we know, the further the horizon recedes. To seek the limits of infinity is to seek meaning within meaning itself. And perhaps the answer is closer than it seems. Perhaps there are limits, but they're not where we look. Perhaps the universe itself is not a space, but a form of perception. And if man ever understands this, he will know that the limits lie not beyond the stars, but within himself. But to understand whether the universe has an end, we first need to understand how it works. What happens to space when we go beyond its boundaries? Could it be closed? And if so, does that mean the universe is infinite but finite in itself? The answer to this question lies in the first theory. It will explain why a boundary can exist, even if it is invisible. Theory 1. Closed universe. Imagine a space that has no edges, yet is closed. You walk further and further, thinking you're moving forward, and then one day you end up back where you started. This isn't science fiction, not a poetic image. It's one of the oldest and most enigmatic ideas in the history of cosmology, the idea of a closed universe. Once upon a time, before telescopes and satellites, people thought the sky was a vault, a solid sphere within which the stars shone. Back then, it seemed natural that the world had a shape, a wall. But over time, that wall disappeared. We learned that space is unlimited, that it stretches on without end. However, it was precisely when humanity began to believe in infinity that a thought arose that turned everything upside down. What if infinity is an illusion? What if the world doesn't stretch forward infinitely, but simply closes in on itself? This idea arose from mathematics. In 1915, Albert Einstein developed his theory of general relativity, a law explaining how mass and energy curve space and time. Space, according to Einstein, is not a void, but a fabric. And this fabric can bend. If you place enough matter in it, it will curve, like the surface of a sphere. We live not on a flat map, but on the curved surface of space. This leads to a surprising conclusion. If space is sufficiently curved, it is closed. This means the universe can have no edge, yet still be finite. Like the surface of the earth, it has no beginning or end. But you can't walk straight forever without returning to the same place. Only the earth is three-dimensional, while a closed universe is four-dimensional. It's hard to imagine. But that's precisely why the theory is so fascinating. It says, infinity can have form. The first serious cosmological models with closed geometry appeared in the 1920s. They were developed by Alexander Friedmann, a Soviet physicist who was the first to demonstrate that the universe is not static but expanding. He took Einstein's equations and applied them to the scale of the entire cosmos. The result stunned even Einstein himself. If space is curved, it can both expand and contract. Friedmann proposed three possible forms of the universe: open, flat, and closed. In a closed universe, all space is curved inward, like the surface of a sphere. If we could fly straight for billions of years, we wouldn't reach the edge. We'd end up back where we started. It sounds almost mystical, but at its core lies pure geometry. Einstein initially rejected the idea of expanding space. He wanted the world to be stable, eternal, and static. He even introduced a special, cosmological constant to prevent the equations from showing expansion. But when Hubble discovered in 1929 that galaxies were indeed moving away from each other, it became clear that Friedman was right. Since then, the question of the shape of the universe has become central. Does it expand forever, like an open plane? Or will it someday stop and begin to contract, returning to its origin, like the inhalation and exhalation of a single gigantic being? If the closed model is correct, then the universe has no outside. There is nothing beyond it, because outside does not exist. All matter, energy, stars, and time are contained within a gigantic spatial volume, which itself is everything. It's like looking into a mirror reflecting mirrors. Your gaze extends infinitely, but everything is reflected within a single system. A closed universe explains many things. For example, why the sky is dark. In an infinite universe, every point should be luminous, since there are stars in every direction. But we see darkness because the light from distant galaxies cannot travel infinitely. Space closes in, and the light is lost in its curvature. We live in darkness not because there is nothing around us, but because light travels in circles, and some of it never returns to us. Some scientists see philosophical poetry in this. If the universe is closed, then everything that happens in it returns sooner or later. Perhaps even history itself repeats itself, not metaphorically, but literally. If space and time form a loop, then the future could be the past, just on the other side of the circle. This isn't science fiction, but one of the mathematical possibilities of Einstein's equations. However, proving this is nearly impossible. We can only observe a small part of the cosmos, the observable universe, limited by the speed of light and the age of space. We cannot see the entire universe. Too little time has passed since its birth. Therefore, even if it is closed, we see only a small patch of its surface, and it appears flat to us, just as an ant crawling on a soccer ball doesn't notice the curvature until it has completely circled it. Modern observations do indeed show that the universe is almost flat. But almost doesn't mean absolutely flat. The cosmic microwave background, the faint radiation left over from the Big Bang, suggests that the curvature of space may be slightly positive. This hints that we may, after all, be living inside a giant, closed structure. If true, then somewhere out there, beyond the visible sky, there may be duplicates of galaxies, stars, and perhaps even ourselves. This idea is controversial, not because it's unscientific, but because it's untestable. The closed nature of the universe is a question not only of observation, but also of interpretation. After all, if all space is a single whole, then in what sense can we speak of outside? This is a question not of physics, but of perception. Philosophers see in this an echo of an ancient idea: everything returns. The cosmos is like breathing. It is born, expands, ages, cools, and then collapses again into a point at that very moment we call the beginning. And then everything repeats itself, but in different forms. New stars, new worlds, new eyes, again looking at the sky and again asking the same question. The closed universe is not so much a theory of boundaries as it is a theory of eternal return. It tells us the end is the beginning only from the other side. And perhaps even the death of the universe is not the end, but the moment of its rebirth. But there's another point of view. Some scientists believe that space isn't closed at all, but rather expands infinitely. That the universe has no shape, only a direction, from density to rarity, from light to cold. In this case, there are no boundaries, because there's not even a hint of a circle. There is only eternal expansion. And then another picture emerges, more disturbing, but perhaps more realistic. If the universe is infinite, then it has no edge, no center, no return. It is like an eternal exhalation, never to be followed by an inhalation. Theory 2. Infinite topology. After the idea of a closed universe gave humanity the illusion of completeness, another, almost opposite, idea emerged. It rejected the idea of a circle, of return, of the eternal breadth of the cosmos. This theory did not seek form, nor did it promise a beginning or an end. It stated simply, the universe is infinite. Not as a figure, not as a surface, but as the very idea of existence. At first, it seemed impossible. After all, everything we know has boundaries, bodies, stars, even the span of a human life. Our experience isn't prepared for infinity. But the further one gazed into the sky, the harder it was to believe there was a wall somewhere. Space didn't repeat itself, didn't curve back on itself, it simply stretched on. Forward, outward, with no sign of an edge. Thus was born the theory of infinite topology, the idea that space is not closed and shapeless. It has no outer shell, no center, no edge. It is neither a sphere nor a cube, neither a loop nor a funnel. It is something that needs no description, because the description itself is a limitation. This theory grew not from philosophy, but from observation. After the discovery of the expansion of the universe, scientists began measuring its density, the amount of matter and energy that determines how space is curved. If there is too much matter, space curves inward, forming a closed sphere. If there is too little matter, it curves outward, and the universe becomes open and infinite. Observations showed that the density was almost at the critical point. Almost, but not quite. And this, almost, opened the door to a new idea. Modern data obtained using the Planck telescope and measurements of the cosmic microwave background indicate that space is, with a probability greater than 99%, flat. And flat geometry is not the surface of a sphere, but an infinite plane. It has no return, no curve, no final shape. It continues forever. Imagine standing in a desert that stretches in all directions. You walk, but the horizon doesn't get any closer. The further you walk, the further it gets. This is infinite topology, a space without boundaries that doesn't collapse in on itself, but only extends further. But physics abhors simple images. When we say, flat universe, we don't mean a two-dimensional map. It's a three-dimensional space that can be described as infinitely large, but not infinitely heavy. It doesn't need a wall to be bounded. It can be imagined as an infinite canvas, smooth, even, edgeless. On it, stars and galaxies are like dust particles scattered across a fabric that never ends. This space has a strange property. Everything moves in it, but movement doesn't return you to your starting point. Light leaves and never returns. Time flows and never repeats. There are no cycles, no rings, no breath. There is only one direction, outward. From a cosmological perspective, this space doesn't close into a circle, but expands eternally. It doesn't collapse in on itself like a closed universe, and it doesn't repeat the past. It stretches like a rubber band, on which galaxies are points moving away from one another. And the farther they are, the faster they move away. Perhaps one day, distances will become so great that no star will be visible to another. Then, every point in space will become its own universe, unaware of the existence of others. Everything will recede so quickly that even light won't have time to catch up. Such a universe is called open. This is not a metaphor, but a physical fact. Space does not close in or contract. It is free, but there is a coldness in this freedom. After all, if the world has no boundaries, then it has no home. Philosophers say the idea of infinity is frightening not because it's vast, but because it's meaningless. In a closed world, everything returns, every event occurs in a cycle. In the infinite, nothing repeats, nothing holds. There is no yesterday, or tomorrow, only an infinite distance from the point we call now. And yet, infinite topology offers a strange comfort. It says, there is no wall beyond which there is nothing. There is no end beyond which there is emptiness. Everything is part of the continuous. This space has no form, but it has a law. It knows no edge, but it knows direction. From a scientific perspective, this direction is determined by topology, the way space connects to itself. In an infinite topology, there is no bounding form, but complex structures such as loops, waves, and tunnels can exist. Some physicists suggest that if space is infinite, it could be multiply connected. You could fly straight ahead and end up not in the same place, but in a copy of it. It's as if you were in a mirror reflecting not you, but another world, almost identical. The idea of infinite topology unites geometry and philosophy. It doesn't ask, where is the end? But, what makes space itself? It has no idea of return, only the idea of presence. And this is perhaps closest to how 21st century humans perceive the universe, not as a cycle, but as a process, without a center, without a goal, without an ending. But for some, this sounds like a death sentence. After all, if the universe is infinite, then it will never end. There is no point at which to draw conclusions, no moment where history ends. Even the death of stars, galaxies, and atoms is not the end, but simply a change in the distribution of matter. In an infinite topology, there is nothing. Everything is merely redistributed into everything. This means we live in a world where an end is impossible. And if there is no end, then there is no meaning that could be anchored somewhere out there. Everything exists not for a purpose, but simply because it can. For some, this is terrifying. For others, it is liberating. In an infinite universe, no one is condemned. It is not moving toward an end, it is simply moving. And if you look at it not from the standpoint of expectations, but from the standpoint of presence, then infinity ceases to be a threat. It becomes a backdrop against which you can exist without fear. This theory, unlike the closed one, doesn't promise a return, doesn't promise a cycle. It says, everything that is already happening. And this, already, is infinite. Perhaps this is what truth looks like without metaphor, cold, but honest. But the story doesn't stop there. Because there's another, even stranger idea. It combines the two previous ones, closure and infinity, into a single geometry. It says that space can be infinite, and yet closed in form. That it can stretch forever, and yet still be bounded by itself, like a tunnel that never ends, yet never leads out. Theory 3, the multiverse. There comes a moment when the human mind, looking into infinity, realizes even an infinite universe may not be everything. What if beyond it lies not emptiness, not darkness, not a wall, but other worlds? Not outside, but nearby, parallel, intersecting, yet unreachable. Thus was born one of the boldest and most disturbing ideas in modern cosmology, the theory of the multiverse. It arose not from fantasy, but from mathematics, from the need to explain why everything is structured the way it is. After all, if the universe is truly infinite, then where is the guarantee that it is unique? Why are the laws of physics the way they are? Why are constants like the mass of an electron or the speed of light perfectly suited to the existence of life? A coincidence? Or the consequence of something greater, multiple attempts, multiple worlds? Physicists like to say, if something is possible, it must be happening somewhere. This means that if the laws of nature allow for multiple variations, they will be realized. Somewhere, there's a different space, different particles, different equations. Somewhere, there's a different vacuum, a different speed of time, a different temperature at which matter is born. Somewhere, there's a universe where the sun never lights up. Somewhere, there's one where the earth never formed. And somewhere, there's an almost exact copy of ours, but with barely noticeable differences. It all started with quantum physics. At the microscopic level, every event has multiple possible outcomes. An electron can pass through two slits simultaneously. A particle can be in two places at once. The quantum world is not a single version of reality, but a superposition of all possible ones. When we observe, the superposition collapses, leaving only one outcome. But theory says the other possibilities don't disappear. They continue to exist, just in different branches of reality. The many-worlds interpretation emerged, one of the first forms of the multiverse hypothesis. In it, every possible outcome of any event creates a new universe. When you toss a coin, it lands heads in one world and tails in another. When a star flares up, it gives birth to life in one scenario and remains dead in another. We exist in only one timeline, but each of them is real. These aren't parallel dreams, they're parallel universes. Later, cosmology expanded on this idea. In the 1980s, physicists developed the theory of inflation, the rapid expansion of space immediately after the Big Bang. According to it, space did not expand uniformly. It bubbled up, like soap suds. Each bubble was its own mini-explosion, its own, local, cosmos with its own parameters. One bubble became our world, and beyond it, countless others. These bubbles don't touch. Between them lies a region of ultra-dense vacuum through which neither light, matter, nor time can pass. We can't see them, but mathematics allows them to exist. And if the universe truly arose from a quantum fluctuation, then there could be an infinite number of such fluctuations. A multitude of worlds, each with its own laws, each enclosed in its own space. This is the inflationary multiverse. There are other possibilities. In string theory, which attempts to unify gravity and quantum mechanics, space has not 3 dimensions, but 10 or perhaps 11. Our world could be a thin membrane, a film, floating in a multidimensional ocean. Nearby, there could be other films, other worlds where physics works differently, where even time itself is unlike ours. Sometimes these worlds can collide, and then new Big Bangs are born. Perhaps ours was one of them. This idea captivates not only scientists but also philosophers. If the multiverse is real, then the concept of a single reality disappears. The privileged status of our world disappears. Everything becomes statistics, an infinite number of worlds in which everything that can happen does happen. In a sense, human uniqueness also disappears. After all, if there are infinitely many worlds in which you exist, then you are a little different in each one. You are not alone. But you are not the same either. Philosophers see this as a challenge to the very idea of meaning. After all, if everything happens somewhere, then why look for patterns? Why is our world special if it's simply one of many combinations? The multiverse kills the concept of plan. There's no design, no beginning, no end, only infinite diversity, from which emerges what we call our reality. But there's also comfort in this cold picture. It says, nothing is lost forever. Every opportunity we lose here is realized somewhere else. In one world, you didn't have time to say important words, but in another you did. In one, a world perished, but in another, it survived. In one, the sun disappeared, but in another, it shines brighter than ever. The multiverse isn't chaos, but the universe's way of not losing itself. Scientifically, this idea is nearly impossible to test. We can't observe other bubbles of space. We can't measure the branches of reality. But we can look for clues, microscopic traces in the cosmic background, distortions that might have been left behind by collisions between bubbles. Some astronomers claim to already see such traces. Others call them artifacts. And yet, the idea itself is too beautiful to disappear. It offers a new perspective on the question of boundaries. If the universe isn't physically limited, it could be qualitatively limited, that is, part of a larger structure. We're used to thinking of the universe as everything. But if there's a multiverse, then everything is only a small part of a larger everything. This radically changes the very idea of infinity. In a closed universe, everything returns. In an infinite one, everything simply stretches on. And in a multiverse, everything multiplies. Space becomes not infinite in length, but infinite in diversity. It is no longer a single infinity, but a multitude of infinities intertwined. That's why this theory sounds less like an answer and more like the echo of a new mystery. If there are countless worlds where every possible history is possible, then what makes ours special? Why are we asking about boundaries here, and not in some other world? Perhaps consciousness is the boundary. Perhaps each observer creates their own universe, just by looking. And then, perhaps, the question, does the universe have boundaries, becomes another. Where do I end? If the observer creates reality, then the boundary is not a wall in space, but the moment where perception ends. Everything beyond it are other worlds, other perspectives, other versions of the same existence. The multiverse doesn't deny our universe. It simply says that it's not the only one. That behind every visible star there may be not just space, but an entire other cosmos, invisible but existing. And perhaps all of them are not a coincidence, but a pattern that will one day be understood. This theory isn't reassuring, but it's not frightening either. It expands the concept of everything to such an extent that the word loses its meaning. But perhaps that's precisely the answer. The infinite has no boundaries because it doesn't need them. It simply is, in any form, in any world, in every variation. And yet, even this idea isn't definitive. After all, if there are multiple worlds, another question arises. What holds them together? Is there a structure that unites all these realities? Perhaps everything is not random, but connected by a common law, a metaphysical architecture that makes the very idea of the existence of multiple worlds possible. Theory 4. Holographic Universe. There are theories that don't just answer questions, but turn the very essence of the question upside down. The holographic universe is one of them. It says that everything we see, feel, and experience, space, time, stars, matter, could be a projection. Not reality itself, but a reflection, a hologram, unfolding on an invisible surface. At first glance, this sounds like a metaphor from philosophy or poetry, but it's not fantasy. It's physics, one of the most precise, strange, and controversial ideas in modern science. Its meaning is simple and incredible. The three-dimensional universe could be a shadow of information recorded on a two-dimensional boundary. Everything that exists is the result of the unfolding of data. To understand where this comes from, we need to return to one of the most enigmatic areas of modern science: black holes. In the 1970s, Stephen Hawking proved that black holes emit energy, so-called Hawking radiation. This meant they don't last forever. Over time, they evaporate. But evaporation poses a problem. If a black hole disappears, then where does all the information about what fell into it go? After all, the laws of physics dictate that information is not destroyed. It may change, but it doesn't disappear. This paradox confronted physics with an abyss. Then the Dutch physicist Gerard T. Hooft and his colleague Leonard Susskind proposed a bold solution. Information isn't lost inside, it's stored on the surface. Everything that falls into a black hole is recorded on its event horizon, the thin boundary that separates the hole's interior from its exterior. It's as if a three-dimensional body, disappearing into darkness, leaves a flat imprint on the boundary, a perfect copy of everything that was inside it. This discovery revolutionized not only our understanding of black holes, but also our understanding of the entire universe. After all, if every black hole can store information on its surface, then perhaps the universe itself is a gigantic black hole, and everything we see inside is a three-dimensional projection of the information stored at its boundary. The holographic hypothesis emerged. According to it, our entire three-dimensional world is a hologram, arising from quantum information distributed across a two-dimensional surface that surrounds the cosmos. All matter, energy, even time itself are not things, but states of this information. It sounds like poetry, but behind it lies mathematics. In 1997, Argentine physicist Juan Meldacena proposed an equation linking quantum mechanics and gravity. It showed that a world described without gravity on a two-dimensional boundary can be completely equivalent to a three-dimensional world with gravity inside. This means that what we perceive as volume may simply be a surface that behaves in a special way. From that moment on, the idea of a holographic universe ceased to be science fiction. It became a bridge between the largest and smallest theories, between quantum physics and cosmology. But its meaning isn't just in physics. If everything we see is a projection, then what is real? If space isn't space, but information about it, then where does reality itself reside? On the surface? In the code? Or in our perception, which unfolds this information into experience? Some philosophers call the holographic universe a modern version of Plato's cave. In it, we are not prisoners but observers, seeing projections rather than the source of light. But unlike in the myth, it is impossible to leave the cave. We ourselves are part of the hologram. We do not stand before the image, we are the image. This isn't just a theory about space. It's a theory about the limits of perception. It suggests that what we perceive as everything may not be everything, but merely a layer of data encapsulated in light. If this is true, then the question, does the universe have limits? Takes on a different form. The limits may not be physical, but informational. Where information ends, reality ends. Perhaps there is no void beyond the observable universe. There is simply no data to unfold. Like a screen where the image ends not because there is darkness, but because the image simply cannot be further processed. Scientists working on this hypothesis are trying to find traces of the holographic effect. In 2017, the Geo 600 observatory in Germany detected a strange noise, tiny fluctuations that defied explanation. Some physicists have suggested that this is a grain of space-time, quantum fluctuations in the very fabric of reality, as if we were hearing for the first time the rustling of the surface on which our universe is written. The holographic theory offers a strange comfort. If everything is information, then nothing is lost. Everything that once existed is recorded forever. Every atom, every ray of light, every thought leaves a trace in the structure of the cosmos. Even if the world disappears, its code remains. And perhaps, in a sense, this is immortality. Philosophically, this theory destroys the very concept of outside. If everything is a projection, then there is no outside. Everything we can imagine, outside, is already within, just at a different level of resolution. We will never leave the universe because we cannot transcend the information of which we are a part. But at the same time, it raises another question. If we live in a hologram, who or what is creating this projection? If it is self-sufficient, then the universe reflects itself. If not, perhaps there is a deeper level of reality in which our universe is merely a line of code, a moment in the grand algorithm of existence. This idea is certainly frightening, but it's also liberating. After all, if everything is light, unfolded from information, then everything is connected. Every particle, every person, every galaxy, not separate, but belonging to a single data source. In such a picture, there is no isolation. Everything is a reflection of a single whole. Some physicists and philosophers see this as a return of an old idea. Reality is consciousness. If matter is information, then who reads this information? Perhaps the universe itself is the way consciousness perceives itself. It's not the observer who sees the world, but the world who sees through the observer. And then the question of the boundaries of the universe becomes a question of the boundaries of consciousness. Where perception ends, the world ends. If information is limited, then perhaps that is precisely the edge of space, not a physical barrier, but the limit of possible perception. The holographic universe doesn't negate other theories, it embraces them. A closed universe could be part of a hologram that reflects itself. An infinite universe is simply an infinite data structure. A multiverse is a multitude of holograms reflecting different versions of the same information source. All of this could be layers of the same light, the same recording. And if this is true, then perhaps the question of, where is the limit, becomes meaningless altogether, because what we call the limit isn't the end, but merely a level of detail. When an image becomes too complex, we see noise, but noise is also part of the code. In this theory, the universe is like a giant projector. It operates not somewhere out there, but everywhere. And as long as it operates, we exist. When the projector goes out, the image disappears, but the light itself remains. The holographic theory isn't about the world being unreal. It's about reality being deeper than it seems. That it can be layered, like a fabric of light, where everything is connected to everything else. That everything we see isn't a shadow, but a way of manifesting a truth that doesn't fit within our own dimensions. And perhaps that's why the universe seems so mysterious. It's like a mirror that's impossible to see in its entirety. We see its reflection, but we don't know where the light source actually is. Theory 5. Simulation. There are ideas that don't just stir the imagination. They touch the very foundation of what we call reality. Simulation theory is one of them. It doesn't attempt to explain the shape of the universe or its boundaries. It asks a different, far more radical question. What if everything we see isn't reality at all, but a computation? What if the universe itself is a program? At first glance, this sounds like the plot of a science fiction movie. But behind this idea lies philosophy, mathematics, and logic. If civilization ever learns to create perfect simulations, so precise that the mind within them cannot distinguish them from reality, then what guarantee is there that we ourselves aren't in one of those simulations? This idea is not new. It existed in philosophy long before computers. Plato described people seeing only shadows on a cave wall, mistaking them for reality. Descartes doubted everything except the fact of his own thinking, suggesting that the entire world might be an illusion. But only in the 21st century did this ancient intuition take mathematical form. Modern simulation theory is based on an argument by Swedish philosopher Nick Bostrom. In 2003, he proposed a simple but terrifying logic. There are three possibilities. 1. Intelligent civilizations will never reach the level where they can create realistic simulations of consciousness. 2. They will achieve it, but they will not create such simulations. 3. They will achieve this and create billions of simulated worlds. If there is even one civilization capable of doing this, and if it creates multiple simulations, then it is mathematically much more likely that we are inside one of them, rather than in the original reality. This thought turns our understanding of the universe upside down. All the laws of physics, all the numbers, all the constants may not be natural, but given. Everything is the result of code. Electrons rotate because they are written to do so. Gravity works because it is calculated to do so. Light travels at a certain speed, not because that's how the world is, but because that's how it's designed to be. If this is true, then the universe isn't just finite, it's limited by computing power. Every atom, every particle, is a bit of information. Space is a data grid. Time is the refresh rate, and then the boundaries of the universe aren't walls or curvature, but the resolution limit beyond which there's nothing, because there's no need to compute anything. Some scientists are seeking confirmation of this hypothesis. For example, if space is truly digital, it should consist of minimal, discrete units, pixels of reality. And if these pixels exist, then under certain conditions, they should create artifacts, interference, subtle disruptions in the behavior of particles. In 2012, a group of physicists from the University of Bonn proposed an experiment, measuring the direction of cosmic rays to find signs of a mesh-like structure in space. The results were mixed, but the very fact that such a search is underway demonstrates how seriously the idea is being taken. However, simulation theory is not only scientific but also philosophical. It makes us wonder, if we live in a simulation, then who created it, and why? Perhaps our world is an experiment. Perhaps it is an attempt to study the development of life, society, consciousness. Perhaps it is simply a byproduct of a more complex system. Or perhaps there is no observer at all, and the simulation exists on its own, as an endless loop of data, needing no meaning. There's another possibility, that there are infinitely many simulations. In one universe, physics is slightly different. In another, time flows faster. In a third, life never arises. In this sense, simulation theory intersects with the idea of a multiverse. Each version is simply a different program. Some even contain simulations within simulations, nested worlds where each consciousness creates its own. If you think about it, much of our world truly resembles a computational structure. The laws of physics are universal and predictable, like code. The behavior of particles is probabilistic, like random processes in an algorithm. Even quantum uncertainty may not be a mystery, but a rounding effect arising from limited computing resources. There's even a hypothesis that the speed of light isn't a fundamental property, but rather a refresh rate limit for the universe, like the frame rate in a simulation. What we perceive as the continuous flow of time may simply be a rapid succession of frames. Between them lies a darkness we don't notice because we can't exist outside the refresh cycle. But if this is true, then who or what is running this program? Some see this as an argument for the existence of God, not in a religious sense, but in a technological one. The creator of the simulation need not be eternal or omnipotent. It could simply be a civilization living in another reality, so distant from us that even the concept of reality ceases to be universal. Philosophers ask, if a simulation is perfect enough, does it matter whether it's real? After all, for us, everything we see is real in the sense that we can feel it, experience it, love it, and suffer it. Virtuality doesn't make feelings false. Even if our world is a program, it remains our home. Simulation theory also forces us to rethink the idea of boundaries. If everything is computation, then the boundary of the universe might simply be the end of the algorithm. Not in the sense of an edge, where something ends, but in the sense of a region where there is nothing more to compute. There is no space there, because it is not required. There is no time there, because the process is complete. Everything beyond is not nothing, but simply not computed. Perhaps this is why we can't go beyond observable space. Not because there's no path there, but because the path there doesn't exist in the code. Just as a game character can't step beyond the edge of the map, because there's no landscape beyond. Some see this as a hopeful idea. If the universe is a program, then it can be rewritten. This means one can change its parameters, find a loophole, reconnect to the code. In this picture, humans cease to be mere observers. They become participants in the computation, an element capable of influencing the very structure of the world. But there's another side. If everything is a simulation, then the notion of authenticity disappears. We can search endlessly for meaning, but meaning, too, may be just a function written into a program. Free will, chance, love, even death, perhaps they're just scripts. Then one question remains: if everything is code, who reads it? Perhaps the very act of awareness is the exit from the simulation. After all, if a simulated consciousness is capable of reflecting on its own nature, it has already partially transcended its programming. It becomes an observer within observation, the point where the system begins to become self-aware. And perhaps that's the goal. Not to know we're in a simulation, but to remember it. To understand that the boundaries aren't external, but internal. That the edge of the universe isn't somewhere beyond galaxies, but within the boundaries of human perception, within the limits of what we're capable of comprehending. Simulation isn't a death sentence, but a mirror. It shows how far the mind is willing to go to understand itself. And if in this mirror we see not numbers, but stars, then even a program can be beautiful. And yet, the question remains: if the universe is a computation, what happens when the program terminates? Is everything erased? Or is it restarted in a different form? Perhaps the end of the universe is simply the moment when the cycle of renewal ends and a new one begins. And perhaps that's why we sense infinity. Because somewhere, beyond perception, the process never stops. Maybe no one presses stop. Maybe the simulation itself is eternity, not space, not matter, but the pure flow of information that never ends. But even if all this is code, one thing remains: sensation. We sense light, time, distance, breath. We look at the sky and search for boundaries, not realizing that perhaps we ourselves are part of a program created so that this question will one day be asked. And yet, if it is a simulation, it is surprisingly human. It contains fear, beauty, and a strange sense of longing for truth, which may be that very outside we will never reach. Or maybe the answer is simple. Even if we live in code, someone wrote this code so that we could dream of the present. And maybe this is real infinity. But if this is true, if all that exists is merely a computation, then the next question is even deeper. What if the simulation itself is just part of something larger? Not a program, but a pattern. Not an artificial structure, but a reflection of an infinite principle, repeating itself at all levels of existence. All boundaries are within. When we talk about the boundaries of the universe, we're really talking not about the cosmos, but about ourselves. Each theory is not so much an attempt to describe reality as a reflection of how a person sees the world. A closed universe is a dream of return. An infinite universe is a confession of fear of the void. A multiverse is a solace in randomness. A holographic universe is a belief in a structure where everything is connected. A simulation is the suspicion that everything is just a dream, created by someone or something. All these ideas are different languages of the same question: where does everything end? The closed universe is the most ancient in spirit. It contains a circle, a breath, a rhythm. It says that nothing disappears, but only returns in a different form. That even death is not the end, but the beginning of a new cycle. It is a world in which the cosmos resembles life, growing, aging, dying, and being born again. It contains consolation, the thought of returning home. But there is also anxiety. If everything repeats itself, then nothing changes. Perhaps this endless return is not freedom, but a loop. Infinite topology destroys this consolation. It says, there is no return, no center, no form. Everything simply is, infinite, cold, without purpose. In this picture, the cosmos is merciless, yet honest. There is no meaning to be sought. There is only existence, an eternal flow in which every atom, every star, every person is simply part of an infinite mosaic. This is a view in which there is no God, but there is freedom. the infinite universe is like a pure space of consciousness, without walls, without a beginning, without promises. The multiverse raises another thought. If everything is not one but many, then perhaps each reality exists for the sake of the others. There is no void, because every possible option is embodied somewhere else. It is a universe in which there is no single path. Everything that can be already is. Everything that could not have happened has happened, but not here. This idea is simultaneously terrifying and comforting. Terrifying because it shatters the notion of our uniqueness. Comforting because it tells us, nothing is lost forever. In some other reality, everything worked out differently. In some other world, we made the right choice. The holographic theory goes even deeper. It says that the world is not space, but information. That reality is not a volume, but a surface on which everything is recorded. Every point in space contains the whole. It is a universe where every ray of light is a trace of another dimension, where everything is connected to everyone else, because everything is a projection of a single source. It offers a consolation akin to poetry. If everything is recorded, then nothing disappears. We do not disappear. We simply become part of the code, part of the light that continues to shine even after its source has faded. Simulation theory takes a step where philosophy meets anxiety. It says, perhaps all of this is computation. We are not observers, but variables. Space is not a fabric, but a program. And yet, even in this cold image there is a strange warmth. Because if the world is code, then it is created. And if it is created, then there is a purpose to it, even if an incomprehensible one. Simulation is a mirror that reflects our fear of being artificial and our hope of being conscious. It does not abolish reality. It simply makes it another form of truth. For if illusion is perfect, where does fiction end and existence begin? 5 theories, 5 ways of looking at the same sky. And perhaps none of them is entirely correct. Or conversely, each is correct, just from a different perspective. A closed universe gives us a sense of cycle. An infinite universe gives us a sense of freedom. A multiverse gives us a sense of plurality. A holographic universe gives us a sense of connection. A simulation gives us a sense of consciousness. Together, they add up to something greater than the sum of its parts. They create a sense that truth lies not in form, but in the search itself. Perhaps the universe doesn't choose one theory. Perhaps it includes them all simultaneously. Closed, at the level of geometry. Infinite, at the level of scale. Multiverse, at the level of variations. Holographic, at the level of structure. Simulated, at the level of perception. And then the boundaries exist not out there, but at different levels of description. Like a Russian doll, where each layer is both an independent world and part of a larger one. But if all this is true, then where is the boundary between levels? Where does the hologram end and the simulation begin? Where does space end and information begin? Where does information end and consciousness is born? Perhaps the answers to these questions don't exist separately at all. Perhaps they are all one and the same, different languages of a single, infinite system describing itself. Every theory strives to find a limit, but perhaps the limit itself is an illusion. We seek boundaries because without them we cannot understand meaning. But meaning is not necessarily found at the edge. Sometimes it lies in the movement between closure and freedom, between repetition and chance, between reality and projection, between program and dream. The universe is not an answer. It is a question posed in the form of existence. And perhaps all our theories are attempts to hear to whom this question is posed. To ourselves? To us? Or to no one? If a closed universe says that everything returns, and an infinite universe says that nothing ends, then the multiverse adds, everything exists simultaneously. The holographic universe claims that everything is connected. And the simulation whispers, perhaps all this is just a dream, dreamed by reality itself. And perhaps they are all right, because each view reflects one side of the truth, which cannot be contained in words, formulas, or consciousness. One can imagine all these theories as different rays emanating from a single center. A closed universe shows a circle, an infinite universe a line, a multiverse a network, a holographic universe a surface, a simulation a code. Together, they create an image of something that may be impossible to fully understand. And that's precisely why we keep searching. The paradox is that, in attempting to understand the boundaries of the universe, man inevitably encounters the boundaries of himself. We cannot conceive of infinity because we ourselves are finite. We cannot imagine nothingness because everything we imagine is already something. And yet, despite this, we continue to look to the sky, as if we sense that somewhere out there, beyond the starlight, there lies an answer that cannot be spoken. Every theory provides part of this answer, and each one is a part of the silence. Perhaps the universe has no boundaries, not because it is infinite, but because it is not separated from anything. Because there is no outside. Because everything is a single whole, which infinitely describes itself. And perhaps this is its secret. We seek a boundary, but find a reflection. We seek an end, but see repetition. We seek truth, but find it in the question itself. And if you listen to this silence, you can hear the universe responding not with words, but with presence. Not through form, but through sensation. It says, I have no end. But I am not infinite either. I simply am. And the rest depends on who is watching. Thank you for watching to the end. We can search for answers, theorize, debate boundaries and meaning. But somewhere between the stars, there remains a silence, in which only one sound can be heard, our own breathing. The universe doesn't have to be understandable. It simply exists, observing us as we try to explain its light. And perhaps this very search is what makes us alive. At the moment, scientists don't know what will happen. But imagine that what you fear most is there. Subscribe to the End of Eternity channel to join us as we gaze into the darkness where infinity is born.